Good evening, everybody. It's Saturday night, my friends, and I'm back. And yeah, so we're going to jump back in to some coding here, my friends, in a moment. Just give me 1 second here. Make sure this is up. There we go. There we go. All right. Welcome on in, everybody. Welcome. Hope everyone is doing well. Hope you're all healthy and happy and all those things. So I have actually done some stuff off camera. Quite a few things off camera, actually. To kind of push us along a little bit here. When we last left off last week, there was a bug in the code where I was, like, my app was just crashing, and it was just, something just wasn't right, and I was just trying to debug it and trying to figure out where we gone wrong and all that stuff. And I finally decided, off camera, like, let's just go grab the Vulkan validation layer stuff, bring that down, compile it, and get that set up. I'm glad I did that off camera because it took like 45 minutes to compile that thing. But I got it all set up. I have it, in my .profile to load up the libraries and stuff. And I changed the code, changed my code to, I had set the validation layers to false in the code, which is what they had their code as. They had their code as true and everything. So I set it to true, and I was able to get the validation layers found and working, and that did in fact help me figure out where I was having a problem. It was in, I believe, it had to do with the images. So where do I do the images at? It should be on here somewhere. Yeah, the image view. So what was going on was, and I didn't really pick up on this when I was looking at the book's image view stuff versus mine. When they build an image view, they take this image pointer that comes in, and they set it to an image ID in here, and they save it. And then at the end of this, they create an image view ID, and they save that as well. And it's very subtle, but later on in the code, there's an area where they're calling the view ID, and there's an area where they're calling the image ID. Even though this says no usages, I do use it here. So in the render that's being used, not the image view ID, and I was giving it the image view ID, and that was causing this image barrier to blow up because it wasn't a correct object that I was looking for, the correct object reference. So got that cleared up, and then I had one more issue after that, and it was that when I would close out the window, the app was hanging, like it wasn't closing entirely, whereas their example was closing when I closed the window, fully closing, fully exiting. And this was an interesting one to find out, but there is if I go back to, this should be like the cleanup here. Yeah, so it came down to this. I was doing a window cleanup first, and then the renderer cleanup afterwards. And the renderer cleanup does all this stuff. And what was happening was the renderer cleanup was getting to swap chain cleanup here. And then right when it was trying to execute this destroy swap chain KHR, it was just hanging. It was not returning at all. And I went online and started looking around, and I found just a random thing here. This image UI thing where someone else had said fixed application shutdown which could deadlock on Linux plus Xorg. But this one was actually this was not linked to that. It was linked to destroy swap chain KHR causes deadlock when used with SDL. And when I then found out that this was referenced over here, I looked at it and I went, oh, they had the same thing where they were doing a destroy window first and then a clean up Vulkan, and then they just reversed it and said clean up Vulkan first and then destroy window. And so then that put me on the path to look at what I was doing in here. And sure enough, when I compared this cleanup, I followed it up the path and I compared this cleanup to what they had in the book examples, they had reversed the order of it in there as well. So once I did that, it now exits properly. So if I run this, you can see that I get a screen, just a black window there, and then I can exit and it will actually shut down, which is good, which is very good. The one thing I'm getting that I don't think the book examples are getting is I am getting this a restricted method in Java-like system has been called. So I apparently am doing something different than what the book is doing. I don't have to track it down. It's coming from the I want to say from memory util. Yeah, it's been called by memory util. So I don't know what I'm calling that's causing it versus it not happening here. It could just be like a version number thing. I don't know. Maybe I have to update the version. I don't know what it is, but or maybe because I have a newer version it's doing this. Don't know, but I'll eventually track this down. I'm not overly concerned about it right now. It could also be that I'm using a different JVM, because I am using a more up-to-date JVM, I think, than this one's using, but maybe. I'll have to look and see. But anyway, it doesn't appear to be affecting the running of the game of the engine, so I'm just not going to worry about it at the moment, and I'll just try to figure it out as we go. So that means that we're successfully done chapter 5 finally, which is good. So I have decided to move on to chapter 6 now. This is chapter 5, chapter 6 here, but really this is what I'm looking at. So chapter 6, which gets us back to trying to draw a triangle, which is all the way down here. And there's a lot of crap to go through. This is where we got to do all the pipelines and all that stuff. Rather than read this thing, which we've already read once before, but rather than trying to go and follow it this way, I'm just going to do it via diffs. And I start out with the main Java, which has some diffs in it, but obviously I don't have these classes yet, mesh data, model data, all that stuff. So I've just put a to-do in there right now, so that I know that I gotta come back to it. So here's what to do. And we're gonna move on to the next part here. It's got debug shaders, shader recompilation. Bug shaders and shader recompilation. Right. So that is just engine config stuff. I'm not going to worry about that at the moment. So the engine, we've got so game logic init. So they've got init data, and then render init data. So engine. So where are we at here? I think I have quite the same stuff there. So I think that's just due to how they're doing things. Yeah, they're calling render init. Which I have here. Yeah, I think I do things a little bit differently, so I don't necessarily need to do anything there, I don't think. They've added this init data thing, which lists the model data that they're using, which is kind of useless right now. So go to graph here, and then we got a model cache. Okay. Yeah. Create vertex buffers, create index buffers. See, again, I don't know why you would put that on something called models cache. Like, to me, these things would be either in a utility. In fact, they would most likely be in a utility. Because they just return transfer buffer. There's nothing else in here except the models map, right? Load models. Again, load model, like, you wouldn't put this in the cache. This is my big problem with how this book writes its code, is that no one in their right mind would lay this thing out the way that they've laid it out. Or at least call these things what they're calling. Like there's no reason for a cache to then also have the ability to load the model. Like, the model should be... Like, load model should be in the model class, I would think. You know, I don't... I mean, I guess technically you're loading the models into the cache, but why would you put... Yeah, I don't particularly like that. I don't particularly like that being here. Because to me, list model data models, which is what they're looping over. What are they doing here? This is just a hash map. See, I would almost have a... I would almost have just a model. Oh, What do you think? Model data. Transfer buffer. These are making mesh lists. It's putting into the map by ID the Vulkan model, which is creating from there. And it's adding the meshes to it. All right. Well, let's see what we got here. So, models cache is what we're looking at. Okay, so how do I want to do this? So we need, let me think here. So engine, I'm gonna do, let's do a new package, say model. And here, so we need the, model cache. Okay. Brilliant. All right. So we have that. Let's see here. So cleanup makes sense. I'm guessing this cleanup, what does that take? Jesus, mesh cleanup. God, I hate that. They pass this whole freaking thing in here and it just, all they need is the freaking device. That drives me up a freaking wall. Alright, so So cleanup says just logical device. And just going through and map that. It's not gonna let me do anything because it thinks it's not correct. Okay, and get a model. So let's just return model map that get name, go, and they have the whole get the whole map. As well, and then the loading of the model, transfer buffer. I guess. Let me think here. Wait. I guess this is fine here. And I'm not a huge fan of it being here, but I guess it's fine for now. So let's say public. Model data.id. I don't know. I guess that's fine. Model data. Data list. Command pool. Base device queue. Alright, we got the EK buffer. Okay, lists. Is this a thing? That's a new thing. Alright, Mulligan buffer. Okay, and let's just tell me it doesn't exist, right? Yeah. Okay. And buffer device. True. True. Oops. The wrong one there. There we go. There we go. And then... Why? Okay. It's gonna begin recording and then, but it's you're doing the new stuff there. Record transfer command, record transfer command. Staging buffer lists. Destination buffer. So I'm trying to figure out what is the minimum amount here. So like these crate buffers, are they? Do they need to be within the begin and end recording? Because to me, when I look at this, I go, we're beginning recording up here. We're doing a bunch of Java stuff, which doesn't need to be within the begin recording. Doing what looks like even more Java stuff here. Although these buffers do go down to the Vulkan stuff. And then we're recording the transfer command from the buffers that we've created. Then we're doing more Java stuff. And then we're ending the recording and submitting it and cleaning it up. And I feel like I would rather have the begin recording than this, the actual recording and then the end recording. You know what I mean? Like, this seems... it's like the B cleanup. Vulkan buffer. We're cleaning up all the buffers we used. buffer B is the staging buffer list, right? Yeah, staging buffer list. Yeah, it's just going through that. Like, I don't, because you got the destination buffer there, you got record transfer command. Right, which you're doing the record transfer command, which is doing the copy buffer. But you're grabbing the destination buffer. Which I am assuming get populated. You know, once the commands actually run, those destination buffers get populated. Because it's just references, just memory references at that point. So, let me think here. So they're just memory references. The only thing we're adding to the staging buffer list are source buffers, so they're the only ones getting cleaned up, which makes sense. Let me think. I'm trying to think here. This, of course, the problem is I'll make this change and then they'll throw some other wrench into it in the next chapter or something, probably. But because my gut instinct is to make a change here, but then I look at it and I go, is it really worth it? Is it really worth making a change here or not? Let me think. What's also really annoying me is like again, this here feels like it should be somewhere else. Like it really feels like it should be somewhere else. Like I should be able to call mesh data dot create buffers. And have it bring me back the vertex and index buffers. I mean, is there a reason to separate those two? I mean, obviously the buffers themselves need to be separate, but I mean, is there a reason to only do vertex buffers and not index buffers? Like, I don't think there is. Because it feels like I could just do that, return both of them as a list, and then just add that list to this other list. In order to clean up. In fact, would I even need to? Like, I could just call cleanup source buffers, right? Like if I put these buffers inside the mesh data, I could just loop over the mesh data again and just say, like, and just call a method that just removes or that cleans up the source buffers. Right? I mean, there's no... And honestly, even like the record transfer command feels like it could be in there too. Because what use is doing one without the other? I mean, I get that we have to record all of them and then just execute them all in one shot so I can see the separation needed there, but I'm wondering if it just makes sense to record the transfer commands. We don't need to know anything about these buffers, really. We just need to know... We just need to be able to call a cleanup method on it. I do need the destination buffer, though, to create the mesh. Which is probably the only tricky part of this, right? I wonder what this, let me see, what does this look like in chapter 7? I'm kind of curious here. Text index buffers. Okay, so it's about the same there. So then how about chapter 8? Okay, loading models, it's pulling in the file nonsense. But this is still pretty much the same. Okay, and then what about chapter 9? Again, that's about the same there. So I feel like this is... Yeah, I mean, the only, like I said, the only tricky part is getting the Vulkan mesh out of it, but I could even do... I can even do that in the mesh data. What are we doing here? We're creating a model data. Model. And then we're adding the mesh to that. Adding the mesh to that. Still a lot going on between begin and end recording. Trying to think of, like, so if I get the mesh data out of there, so if the output of this is how do I want to do this? What I want to do is reduce the amount of crap between begin recording and end recording to just the things that are actually being recorded. It wouldn't hurt to have multiple for loops because it wouldn't hurt. Like I could do a loop that just goes through and creates models from the model data. And then And all I need from this is a reference to destination buffers. That's all it's doing. So really, I could probably pull both that and that out into another loop. I mean, it's looping, it's got a double loop in here anyway. It's looping over the mesh data. But yeah, and this is looping over the model data, which is what was passed in. So I wonder if I... How would I do this? What would be the best way to do this? I guess... model data meshes. Let me think. If I were to put in the model data, like I would almost have to, I would have to move this logic basically into model data and have it operate just on the meshes. Oh wait, it's getting model data.meshes, right? So the meshes are already model. The meshes are already associated with the model data coming in. So what is the point of having two different classes here? Like, I get that later on they're going to load this from disk, but like when you load it from disk, why not just build a Vulkan model? Like, what is... all you have is a string ID and a mesh list with Vulkan mesh, and this just has an ID and a couple... this is just a record. It's an ID, a couple buffers, and number of indices. Right? So why wouldn't you just build a... why are you building this at all? Why wouldn't you just build a freaking Vulkan model with the Vulkan meshes in it already? Because you've already got the freaking data, right? Because these are just pointers to destination buffer. right? There's nothing in there yet until this record transfer, until this submit and wait happens, right? So why the extra step? I don't get the point of that. I mean, I know that later on they're going to dump out model data into a JSON structure, and they're going to read the JSON structure in. But again, you could just make the JSON structure Vulkan model, right? There's nothing crazy in here that you couldn't do. I mean, the mesh thing is, and you know, the mesh would just be. I mean, I get that these buffers don't make any sense in JSON, but you're still going to have to build them anyway, right? So where does that get built? So those get built probably here, right? Because this takes mesh data. Well, let's take a mesh data positions. Yeah, create new transfer buffer, source buffer, destination buffer, and then that is getting set in on the constructor. Vulkan mesh construct. Yeah, of course, because it's a record. Yeah. So we still have to initialize those buffers with this, but I mean, yeah, I mean, we still have to initialize them. So, because otherwise they'll be null and it's not going to be useful. So, if I pull this apart, we're going to lose that piece of it. Well, not really, because I'm going to have the Vulkan mesh be created as part of all this. Right? Like this and these can be created together. This and this can all be done together. And then we just have to loop over and do the record transfer commands. Unless I'm smoking something here, but that's, yeah, because these are just memory buffers. Right, so yeah, I'm going to change this because this is kind of, I don't like the way this is being done here. Like whenever I see something begin and end, my initial my gut feeling is there should be as few things happening in between those things as is absolutely necessary, right? So like, if the more you do between that and that, the more it feels like you're doing too much in one spot. So like this, like when you have a begin and you have an end, the things in the middle should be related directly to the begin and the end, in my opinion. Otherwise, you just like someday I'll come back to this and have to try to make this perform, and I'll be shit out of luck. You know what I mean? I'll be like, well, there's no way to make this perform now because it's doing 5 things instead of one thing, right? So then this really should be, instead of model data, we're going to call this Vulkan model. Model lists. Okay. And okay. Well, we gotta work on Vulkan model then right now. So to do there, and let's see. Yeah, Vulkan. So Vulkan model is right here. So let's go new Java class Vulkan model. All right. We got private string ID, private lists, Vulkan mesh, mesh lists. All right. No, I don't need to do that. Let's do it here. There we go. And then clean up. Mesh cleanup. Okay. So public void cleanup. Device and mesh lists. I'll just put a to do here. Then get the ID and get the mesh lists. That's not what I want to do. I want to do this. Cool. All right. We have that, and then in addition to that, so wait. So before I go any further, let's get this. Let's get Vulkan mesh here. New Java class. Vulkan mesh. All right. They have it as a record. I can make it a record. Wait, do I want it to be a record? Let me think. It could be. It could be a record. Let's do string ID. And public void peanut. that for a second here. And let's get this Vulkan buffer thing going. What is this at? Wait, org Vulkan being... Oh yeah, Vulkan book. Okay, so I'll just put it under model for now. All right, private long completion size. You know what? I'll just call it buffer. The hell with it. Private enter buffer. Requested size. Okay. Wait, did I get this from the right? Yeah, chapter 6. Okay. Alright, public. Welcome buffer. Logical device. Size. Usage. Okay, requested. This dot requested size is size. It's not map to memory. Is okay. Memory util dot null. Stack that stack push. Get device. Oh, I see. R buffer creates info. Buffer create info. Colic on the stack. Okay. Let's type default. Size of these. Size. Or, you know what? Usage is usage. Sharing mode. Okay, 13. Okay, sharing mode exclusive. Yeah. Alright, long buffer. Long one. If needed, VK 13 VK create buffer. Device that gets device. Create info, null, buffer. Okay. And this dot buffer equals long buff dot get 0. Get buffer memory requirements. Okay. Requirements. Wait, what am I doing? Jumping ahead of myself here. Okay, 13 EK gets buffer memory requirements. Device. Buffer. Requirements. Okay. Okay, memory. Okay, info. Stack. This is S-type default. Allocation size is memory requirements dot size. Memory type index. We type from properties. Okay, that's something else I gotta do. So what is that? We type from properties. VK memory properties, memory types, requirements mask. Okay. So this definitely looks like it goes into the utility. Public static int, memory type from properties. Static int get memory type. Logical device. Type bits. Let's ask. All right. Okay, memory type dot buffer equals device get physical device get VK get memory properties. Types. Okay, max memory types. Where does this come from? Ah, me see here. So DK13, DK mix, memory types. If type bits logical AND with 1 is equal to 1, and memory types dot get I property flags logical AND with the requirements mask equals requirements mask. all the flags are set. Results equals I and break. So we're just trying to find the very first thing that matches all the requirements that we have. Otherwise, type bits bit shift to the right 1. Okay. If results 0 is less than 0, runtime exception, memory type not. Otherwise return results. Oops. Okay. So by shifting to the right 1, we're multiplying it by 2. Basically just looking for the next okay. Alright. That's fine. So this is doing Vulkan, utilities, get memory type, device, memory requirements, that memory type bits, ask, okay. If needed, VK13, VK, allocate memory, device, get device, memory allocation, null, they're reusing that long buffer? Okay. Okay, the allocation size. Okay, so this dot allocation size equals memory allocation size. This dot memory equals buff 0. This dot pointer buffer equals memory util dot mem alloc pointer 1. I don't know why this is just to free it up, I guess. But what is the point of making it? That's what we're using to map the memory. Okay. Okay. So then, Vulkan utils, if needed, and bind buffer memory, device, get device, buffer, memory, 0. Okay. So then we have public void cleanup. Buffer, VK, destroy buffer. What are we at? As far as that is concerned, device, get device, buffer, and null. Free memory, device, get device, memory, and a null. Alright, good. And then we got get buffer, get requested size. So get buffer. Didn't want that. Get requested size. And then we have public map. Guessing logical device probably. If memory equals null, then that's the correct null, right? Yes. Then what we got? Vulkan bills, elf needed, VK, 13 VK, net memory, device, get device, memory, 0, allocation size, 0, and pointer buffer. memory equals player buffer get 0. Turn map to memory. Alright. And would unmap. Do that device again. And it's basically the same thing, roughly, kind of. If map to memory does not equal tilde null, then VK13 VK on map memory device get device memory, and then map to memory equals tilde null. Okay. So this is written now. So we go back to Vulkan mesh here, and all this is now correct. Okay, and then back to Vulkan model. Okay, mesh lists. So then for the cleanup, we just do a Vulkan. Oh, no, I can't because I gotta give it the device, right? That's not gonna work. So we do have to do it this way. There we go. Okay, so that's model done. Well, kind of. Not entirely, because I want to do some more changes here. So that brings us back to this. So Vulkan model. Import class map. Class lists. There we go. Okay. All right. So, ow. Think here now. We're going to do this. So, create. So we have the Vulkan models are already going to be created. Prior to calling load models here. But I still need to when we do it though, I need to create the Vulkan mesh to put in there. Which is going to need a reference to these buffers. Oh, man. It's going to need a reference to those buffers. So I feel like I need to, under the model, Mesh data indices. Mesh data indices. Why is and that's just doing the mesh data indices length. Okay, I think I know what I need to do here. What I'm gonna do is say public void add mesh. ID and size or number and the season. Right, and then this will do now. Just a record of positions and indices, right? do... I guess I'll keep these as arrays. Because it is a little bit more compact that way. This is the one case where it's a little bit more compact way of doing it. Okay. So then in here is where we have to do basically most of this. Transfer buffer. Vertex buffer, create index buffer. Give you vertice buffers, indice buffers. I want to, so under mesh here, I guess it's not, I guess I wouldn't put under mesh then. Well, some of it would be there. We need transfer buffer first before we do anything here. Trying to be trying to make sure I leave to-dos around for myself, because if I stop in the middle of this, I want to make sure I remember where I was. It's just a record. Okay. All right, so this will be Vulkan buffer, source buffer, Vulkan buffer, destination buffer. Record transfer commands. Yeah, all right. Transfer commands. Try. Stack push. BK buffer copy. Buffer copy. Stack. Source offset 0. Destination offset 0. Size would be source buffer to get requested size. Alright, and then VK13 VK command copy buffer. Command buffer, source buffer, get buffer, destination buffer, get buffer, copy region. Okay. Alright, and then in addition to that, I want a public void cleanup source buffer. Need logical device. All right, so we have those there. I'm also going to need probably to grab the destination buffer, but let's cross that bridge when we come to it. Okay, so I need to create the vertex and index buffer. So I need the method to do that.
What the fog of war means is war is so complex, it's beyond the ability of the human mind to comprehend all the variables. Our judgment, our understanding are not adequate. And we kill people unnecessarily.
So let's do private transfer buffer, create vertex buffers. Which means I need to pass the logical device in here. So we do that. And then this is okay, vertices, we have that. Vertices at length. Alright. Buffer size is elements times port size, which is I actually have this somewhere else, don't I? Vulkan. Do I have these somewhere? So I had a constants thing here. Device, space device, queue, command buffer. I don't have one? I thought I had one. I was almost certain I had one of these somewhere here. But I can't find it. Let's just create another one. Why not? And then if I find the other one, we'll just change it over. Public static final int size. Max in flight I actually put somewhere else, but sorry. Actually, I wonder if I can find that. Max in. Put that just in the renderer. Yeah, because it actually made more sense there. Oops. Alright, so then if I come back here, let's say book size. And our source and destination buffers. Device, buffer size, buffer usage, transfer, source bits, and memory, property, hosts, visible bits, board width, VK, property hosts, coherent bits. Okay. We should buffer. Nice. Buffer size. For usage, transfer destination bits. Board width, VK. Buffer usage vertex buffer bits. And then VK13, VK memory, property device, local bits. Okay. Map. Float buffer data equals util buffer empty memory source buffer get requested size. How are they doing that? So roses number of elements by 3. Wait, isn't there like a way to just load? Row is 0, row is less than rows. Row times 3. But you're... Oh, it's rows is positions length divided by 3. But why is this even necessary? What am I missing here? Because all you're doing is, I mean, yes, they divided by 3. Great, but you're still loading everything into there. Like it's just loading everything into the buffer. Because it's gonna be 0, 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11. Like I don't. What is this? Why? What is that accomplishing? Like, because you're assuming everything's in order anyway. And if you don't have 3 positions, it's going to fail. I don't know what they're trying to do there. Because it's just data dot. Okay. You can literally put float source, like a float array. So am I missing something? And actually, they're not even... That doesn't even... Wait a second. Data? Float buffer, data... Dot put... how is that working? They're not even putting anything, they're not putting any value in there. Or, well, they're not specifying the index to put something at. Am I just going crazy here? Float buffer put Java NIO float buffer put float F. What? Oh, I see. Here we go. You can just. So what does this do? Bulk put method transfers the entire content of the given source float array into this buffer. An invocation of method in the form destination put A behaves exactly the same way as the invocation destination put A0 A dot length. Okay, so if I just put this, then that's equivalent to what they just did there. I feel like I'm losing my mind here, because this like is completely unnecessary given that they're just putting it in sequence, right? Which is the same as just doing this. I don't know. Maybe I'm missing the forest for the trees there, but we're gonna roll with that. Source buffer unmap. Map that, and then turn new transfer buffer, destination buffer. Okay. It's the create vertex buffers. Typo in word vertices. It probably is. It probably isn't spelled right, but you know what? Who cares at this point? Vertices, and then create indices. And look, he does it here. He just throws all the data indices in there with the int buffers. I don't know why he does this other crap with that one. I don't know. I don't know. Move it. Transfer buffer. Create index buffers. Device. Indices. And it's basically the same, right? So int number of indices. Buffer size is indices times int size r source buffer new token buffer, device, buffer size, 13 VK buffer, usage transfer source bits, and then the mask VK13, VK memory property host visible bits stored with VK13 memory property host coherent bits. All right. Our destination buffer is new. Bulk buffer, device, buffer size, VK13, VK buffer usage transfer destination bits, and VK stored with VK13, VK buffer usage index buffer bits, VK13, VK memory property device local bits. Go. Source buffer map. Alright, and then ints buffer. Buffer, so map memory, int source buffer, get requested size, data put, indices, source buffer, unmap, and return new. Transfer buffer, source buffer, destination buffer. Okay. So those are done here. Now I need to add mesh here. I need to do source buffer. Yeah, I don't need to even return the staging buffer list because I can just go through and say, get me all the meshes and do a cleanup on the source buffers, right? Except ultimately what they're doing that for, yeah. Yeah, so source buffer, and mesh. Got it. So we'll do yeah, all right. Transfer buffer vertex buffers, vertex buffers, device, vertices, transfer buffer, index buffers, indices, versus indices, call record transfer command on there. Or you can just return a list of transfer buffers, right? Although, maybe not. Maybe, because I'd have to then pass that transfer buffer around. Because the mesh needs the buffers, right? I can do private list transfer buffer. And what we'll do is we'll add these. Right. We'll add those there, and then we'll say so mesh lists, add new Vulkan mesh ID, text buffers, destination buffer, Index buffers, destination buffer. Indices dot length. There. Okay. So I got these, and then all I need to do then is grab the transfer buffers out of here. To be able to call record transfer command on them. With the assumption that add mesh has already been called before getting here. So then back to model cache here. So do begin recording, and then I loop over the model list. Loop over the model lists. And get all the transfer buffers. Because that's at the Vulkan model level, right? Yeah. That'll be all of them for all the meshes that I've loaded already. So I can just say model lists for each. To get wait, did I not give myself a getter for transfer buffers? I didn't. Transfer buffers. I'm going to do the traditional for each here. Vulkan model lists. Because I have to loop anyway to get the sort of. Model dot transfer buffers for each. I can't do that. Well, I can, but it's. Transfer commands. Let me get? No, it's fine. Okay. All right, so that will record all the transfer commands. Everything is set up there, and then we just do command and recording. Submit and wait. And then command cleanup. Nice. Cool. Okay. And the staging buffer list is just, what's all the source buffers? Right, so I would just go through and say, I'll get I'd have to loop again, right? Yeah, I have to loop again. That's fine. I could do, some prep work here actually. Let's do lists, buffer, transfer buffers equals new array lists. And we go for just do model lists. Actually, I can just do model list dot stream collect no, it's gotta be map, alright. Okay, transfer buffers. That, this is gonna have to be reduce Now collect. It's gonna be a little bit interesting. Collect. There's collection. No, this is not right. This is not right at all. Each class into one list. See if this works. He's not. Why not have Copilot work in here? Oh, I'm not signed in. Okay, hang on a second here. Get a little bit of help with this, get a little bit of help with this, thing here. One second here, friends, while I do all the doobity doos. Log in. That. Nice. Okay. Good. Is that now working? All right, looks like I've got stuff back here. Bring the screen back up. There we go. All right, so can I? Is this not activated? Why do I have this set to do inline? Let me see. What's the go to settings? pilot. Enable completions, disable completions. Button 5, click. Yeah, that's what I thought. If I have it on or off right now. Or the other doesn't appear to be working. Let's do. So, oh yeah, I was wondering if I would need it like a flat map. Okay, because I was looking at this, I'm like, I wonder if that's where I've gone wrong. Okay, lambdas are always kind of a weird. Oh, see now it's working. Lambdas are. I'm still trying to. I'm better with lambdas than I have been in the past. I'm still learning them. Yeah. Collectors, 2 lists. Let me guess, this should just be 2 lists. Maybe replaced with 2 lists. Yep, that's what I figured. Okay. I can turn that off again. Cool. So I'll map all of those transfer buffers to here. Right, and then I can just loop over those. Right. And down here, I can just say, clean up the sources. So, transfer buffers for each. Clean up source buffer. Oh, it takes a thing, doesn't it? Yeah. There we go. All right, that's a little bit, I think, a little bit cleaner, but we'll see if it still works at the end of the day. I think that's a little bit cleaner, but we'll see if that even makes any sense once we get to it. All right, and then model map cleanup. We can just do. Go. Excellent. So I've got that all in place. And I think I have it in a better form, I think, potentially. We'll see. Okay. Alright, good. I'm actually gonna step a little early here, my friends. I done 2.5 hours, and I think we got quite a bit accomplished in the 2.5 hours. At least for chapter 6 here. We got a lot. We got the, we're loading models and stuff in here. I've got a lot of to-dos still to do, but it's not too bad, I would say. What else we got? Where's my so we got stuff to do in render. We got transfer buffer done, Vulkan mesh is done, Vulkan model is done. We gotta make changes to render. Models cache is done as far as I'm concerned. We got a little bit of changes to scene render. Vertex buffer structure. What the ever living hell are they doing here? Input attribute description buffer. We'll cover that at some point. I'm not liking the fact that we've created a class called vertex buffer structure. Because that just feels like a direct translation from C without any thought put into it. So we'll see how that goes. And then we got to do all the pipeline stuff again, but these are all brand new classes. Pipeline cache. Then we got to do the shader compiler, which I really have the shader compiler already, but I think what I'm going to do is just kind of maybe pull it over. Actually, we'll probably just rewrite it. We'll probably just write it again. Doesn't matter. It doesn't matter. It's not that big a deal. Shader module. We've already got vertex buffer done. They're adding pipeline cache to this ginormous class, which doesn't make any sense. We have the constants already in there. We have the memory type from properties, so this is done too. So we've made some decent progress. There's still a lot with the yeah, I got rid of model data and mesh data because screw that. Resources, and then we've got what targets I don't care about. Shaders then, right? Just 2 shaders to do, which are very, very simple. So we're a decent amount along. I mean, we still got we got a lot of pipeline stuff to do, which, as I recall, was just a lot of a crap ton of info structures and things to put together. And we'll see. I'll probably will put some of these in the structure utility thing, just to kind of get these classes to be a little bit. I don't like constructors that go. I don't like classes that run on, but I also don't like constructors that just do 5,000 things like this. I mean, I know that's kind of the point of the constructor, but at the same time, I'd like to reduce the size of them so I know what's at a glance what's going on instead of like having to jump back and forth constantly. And some of these too are like, but we'll see when we come in here, but I'm guessing some of these are also like you need to create these 2 info things just to pass into another info thing to just get the 1 info thing out. You know, it's not, a lot of these are like in between structures that could just be pulled into another method and then done all at once, and then you just get the result of that back, and then you don't need 9,000 of these things. So there's that. Yeah, I think we're a decent clip there. And then at the end of all of this, whoops, that's the wrong one. At the end of all this, we'll be back to displaying a triangle, a red triangle, which is good. And then I think it was, I mean, this chapter, I think we can probably get through next week, most likely, depending on whether I run into another design thing that I feel like I need to deal with. I think it was chapter 7, though, if I'm not mistaken, that was, you know, the going 3D thing. That was like a ginormous bear of a thing here. Although maybe not, because I kind of scrolled through that a lot quicker. So maybe they've optimized it a little bit better than what they had before, because they're doing this different method. Because I see a lot of render changes, resize, pipeline. Yeah, and then chapter 8 was where we were before, and this is where we were doing complex models and textures and stuff. Maybe it's chapter 8 that I'm thinking of, where we just started going off the deep end with a ton of stuff. Let's see. Yeah, there's a ton of stuff in chapter 8, but if we can get all the way to the end of 8 here, and I'm going to try, instead of using a cube like they have, I'm going to try to load that spaceship model up that we have and have that spin around, which I think we'll be able to do. Then we'll be back to somewhere. We'll be back on track, hopefully, at that point. But we'll see. That's going to take a little while. It's going to take a little while to get there again. But once we get there, I can then push everything that's on this branch down to the master and overwrite what was there, and then we'll be back in line with the way that the book is doing things. For now, unless they go and change it all over again, which I wouldn't put it past them. So this is good, at least. I'm learning. And honestly, it's not doing this a second time around, though it's arduous to watch. It's actually, repetition is actually helping me a bit in kind of learning more about what's going on. The other thing is, too, the other advantage we have now that we didn't have before was because I went and took the time and compiled the validation layers in. So now if I run into errors, instead of me just getting some random core dump that I can't really do much with, in theory now I'll get some more helpful logging information that'll at least point me in a direction. So that'll be good. So yeah, and that's it. That'll be it for me for tonight, my friends. Tomorrow night, what are we gonna do? I don't know yet. I'm in a toss-up between starting another No Man's Sky expedition and doing any number of the other games that we have in flight, or even possibly just doing some random game on the side. I don't know right now. Um, so we'll play it by ear and see what happens. But I think Monday night I should be back to Dragon Quest One Remaster. We'll make some more progress there. And actually, I'm going to see about... We might do that probably Monday and Tuesday. Just to see if I can maybe get to the end of that and have at least one thing off the list. We still have to get back to Slime Rancher 2. I've done a little bit here and there off camera in Slime Rancher 2 to kind of make some progress. There's a lot of grinding stuff, so it's not, you haven't missed anything too spectacular there. It would be nice at some point to get back to The Last Caretaker, because I'm enjoying that game a lot, but I'll give it a little bit of a rest for now. It's in early access, so we got plenty of time to, fool around with it. And we definitely need to get back to Shadowrun Returns, because again, or Shadowrun Dragonfall, because again, I want to try to get some things off the list if we can. I want to complete some games because I'm enjoying all of them, but I definitely do want the satisfaction of having completed them too. So there's a lot going on there, a lot of stuff in the air. I don't think there's anything coming out this week. I could be wrong on that, but I don't think there's anything that I've been waiting for coming out this week. It would be nice to jump back into Duck Off as well, but we'll see. We'll see. I have too many options as usual, and it comes down to what I'm feeling. It might be, I don't know. I'm almost to the point where I'm like, maybe I should just stop scheduling things and just play whatever, and I'll eventually get things done. But I don't know. We'll see. Or maybe I should, I've thought about maybe I should focus on one thing until it's done, and then just keep going through the list that way by focusing on one thing until it's done. But I don't want to lose the variety nature of what I'm doing. There's a couple, by that I mean there's a couple of variety streamers that I watch that are right now kind of stuck on games that I don't care for so much, and so I haven't really been watching them because they're playing stuff that I don't really care for, and they've been doing it for weeks, last couple of weeks. So I'm like, and I was kind of feeling the same thing with The Last Caretaker. I love that game and I was playing it every day, but it wasn't really, if you don't like that kind of game, then there's not much for you to come back for. So I'm gonna I'm gonna keep juggling and seeing if I can get through some stuff, and we'll see. We'll see. I mean, it's going to take me a while, as usual, because I don't have that many hours of the night to do it. But, we'll get somewhere. We'll get somewhere with it. Anyway, my friends, that is it for me for tonight. If you happen to run across this on the YouTubes, and you have a like and or subscribe that you can toss my way, that would be really swell and awesome and great, and I appreciate it tremendously. I'm trying to get to 500 subscriptions, so 500 subscribers and 3,000 watch hours, so we can get to the first tier of YouTube. That would be really great. But otherwise, thank you so much for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. I hope to see you back here again in the future for some more stuff that happens to suit your fancy. Until then, see you, bye.
Who are you and how did you get in here?
I'm a locksmith. And I'm a locksmith.